Hi, my name is Johan and today I will be presenting a quick technical update about what we have been doing. We have not been sitting still last year and also a few exciting things that we are releasing later this year that I'm really happy to be able to show you today. So first, a few updates about the Things Stack. So in last year we added a couple of new features, including LoRaWAN 104 support and the latest version of the regional parameters. And this means that we also support LoRa FHSS, which is the modulation that will primarily be used by satellite communication. So that's also really exciting. We also improved our adaptive data rate algorithms, and we added a lot of settings that you can use to fine-tune the data rates and the transmission powers that your end devices are using. We also added a couple of new integrations, including Azure IoT Hub and IoT Central integration, and we also added health statistics of your webhook integrations. So if you have a webhook integration and the server is a bit slow or it's down, we'll give you notifications. We added bulk import, so if you want to migrate your device fleet from another network server to the Things Stack, or between the Things Stack deployments, or if you want to import CSV files with end device data, you can now do that. And finally, in Packet Broker, we added advanced routing policy configuration and gateway visibility configuration and support for LoRaWAN backend interfaces, but more on that later. So the Things Stack, as most of you probably know, supports 4 different deployment models. We have the Things Stack Cloud, which is our fully managed environment with all our feature set enabled. And the Things Network is also a managed environment, but that is for the community network, where everyone works together in one collaborative way, which is intended really for public use cases. You can also run the Things Stack yourself. We have the enterprise distribution, which is our fully featured commercial setup that you can deploy on your private cloud or on bare metal if you want. And finally, we have an open source distribution that you can find on GitHub, and that makes it really easy to get started. All these, the Things Stack deployments, they share the same API and the same configuration, and that means that you can pretty easily start on the Things Stack open source, and when your deployment grows, you can migrate to the Things Stack Cloud. On the Things Stack Cloud, we have our service, public service status page that you can find on status.thethings.industries. And yeah, we are pretty proud and happy with our operational performance the last year. We have been seeing 100% uptime since June last year, so we are really excited about that. The Things Stack is open source, has an open source core, and you can find on GitHub the Things Stack source code, but you can also see the internal issues that we track and also the milestones. And so we produce roughly 20 releases per year. That means that every 2 or 3 weeks we have a new release, and we update the Things Stack Cloud and the Things Stack Community Edition also every 2 or 3 weeks with the latest version. If you want to see what's coming in the next versions, go over to GitHub, to our repository. You can find that on github.com/thethingsnetwork/LoRaWAN stack. And you can see exactly the issues and the milestones and everything that's coming up. And if you want to request a feature, or if you have a bug report, please also do that on GitHub. So it's open source as a core, but also we are really transparent with our development process. We have 2 exciting new features on the roadmap. First is the notifications service, and that is a service that will send you text messages or email notifications of things that you should know about. And we are going to add this gradually in the versions that we are releasing this year. First, we start with some basic administrative and security notifications. So if you are a tenant administrator and a user signs up that needs approval, you will get a notification for that. So those are really simple things that we start with. Later on, we add notifications for events of things that happen in your network that you should know about. For instance, when a gateway goes offline, or when a device joins for the first time, so that you know everything works. And you will be able to configure events for that as well. And finally, we'll be adding notifications for more advanced network behavior. And that includes any anomalies with gateways or devices, but also suggestions for potential other networks to configure peering with through Packet Broker. So that's one of the two big features that we'll be adding later today. The other one is the Network Operations Center, and that will provide historical insight in the performance of your network using mostly nice visualizations in the browser, and it's fully integrated with the Think Stack, and it's powered by Grafana. And I think most of you know Grafana. It's an open source, really well and fully featured dashboarding tool. And so we build an integration with that. Examples of this that you will be able to see are the gateway packet rates, channel utilization, the channel noise, how many devices are seen by your gateway, devices that are seen that are registered to other networks, things like that. But also on a device level, you'll be able to see the historical data rates, to see how the ADR profile is working, as well as the packet loss rates based on frame counters that are not incrementing, but also which gateways are covering your devices and what the RF qualities are. Finally, on a group scale, so devices that belong to applications, we will be analyzing the device health in the application. So that's really exciting. So this is a lot, and we will do our best to make it really easy and digestible for you as a user. So it's going to be available only in the ThinkStack Cloud and Enterprise, and it's going to be accessible for tenant administrators. So we built a first version, and this is what it currently looks like. So here you see a gateway performance, and you can see the timeline here. You can select historical time, and you can zoom in to find particular time windows that are interesting for you. You can really zoom in to the 5-minute level and see exactly what the traffic flows are, channel utilization. You can quickly switch to another gateway, select the time window, see the channel noise and all those things. So this is only for a gateway, and again we are adding more views to this gateway view, as well as these sort of visualizations, but then for end devices. So then Packet Broker. So Packet Broker is our LoRaWAN backbone for interconnecting LoRaWAN network servers. So if we look at all the features that make LoRaWAN as a communications technology unique, so I listed them here, you see that Packet Broker basically addresses most of them. So ultra low power is improved by using Packet Broker, because your end devices will be able to use gateways that are potentially closer to your end devices than your own gateways, if you set up peering with other networks that are also active in your area. It also leverages the long-range capability of LoRaWAN, and also the fact that it's shared spectrum. So gateways already receive messages for other networks already. And so what Packet Broker really supports is making sure that that traffic ends up on the right network. Packet Broker also supports this public and private deployment integrations. For instance, the Things network, the community network, is a public network, and you may want to use that coverage in your private network. So you want to keep your devices and your gateways and your applications and everything private on the ThinkStack Cloud with an SLA, but you still want to use the coverage of the Things network and also contribute your coverage back to the Things network. And this is a typical use case that Packet Broker supports. Since Packet Broker is just exchanging traffic on the network layer, all existing LoRaWAN security features are still working as you expect them to be. So Packet Broker is just passing around a physical payload as it is received by gateways, and the serving or the home network server will be able to process the message once it gets routed by Packet Broker. So all the ThinkStack deployments are currently integrated with Packet Broker, but last year we also added support for other LoRaWAN network servers. So we have interoperability testing. We finished that with Actility's ThinkPark Exchange, which is a LoRaWAN roaming hub with a lot of other networks connected, but also with ChirpStack. So we know there are a lot of smaller networks that are using ChirpStack. They can now also connect with Packet Broker and also Loriot. We also finished interoperability testing with them. So if you are a customer of Actility or of Loriot, you can file a support ticket and you can make sure that you can configure sharing your network coverage one way or both ways with the Things network or with any of the ThinkStack Cloud customers. Today, the LoRaWAN traffic is growing rapidly. So we're seeing roughly 60% year-over-year growth in message volume. So that means that this whole LoRa ecosystem is growing fast and is in a really healthy state. Today we are, I just looked at the statistics, we are routing over 1,200 messages per second, and that equals to almost 40 billion messages per year. And that's already going through Packet Broker right now. If you are using the ThinkStack, you can configure routing policies. So these are fine-grained policies to configure which traffic goes from your network to another network. So if you have gateways and you want to contribute or you want to send traffic from your network to another network, you can configure that using routing policies. And this is all well integrated in the ThinkStack console. And what you can, for example, configure is whether you want to, well, you can see the settings here on the screen. So you can, for example, only share join requests and allow other devices to join your network. Uplink messages, downlink messages, you can select that exactly. You can also use this policy that I have here as an example and not allow other networks to send application layer downlink via your gateways. Those are typical routing policies that you can configure. So we give you a lot of control using that. If you are not using the ThinkStack, if you're using Actility, ThinkPark Exchange, Loriot, or ChirpStack, you can also configure this, but you have to use the command line. But we still support this fine-grained routing policy control. Another part of this technical update is about the device repository. The device repository, for those of you who don't know it, is the largest collection of LoRaWAN devices. It's a structured collection, so it's a database, so to say. It's an open source database that includes LoRaWAN device profiles, payload codecs, so those are the small scripts that are decoding binary payload into meaningful data and the other way around. But it also includes more information about the end devices, like hardware versions, firmware versions, the sensor types that support, any other regional compliances and things like that. We have almost 3,000 LoRaWAN device profiles in there, and they are contributed by the community. So typically device makers do that themselves. But if device makers struggle with adding their devices, the Things Industries is also there to help and to assist. So there are 90 vendors in there right now. We have over 300 verified codecs with a lot of test cases, and over 100 people already contributed to the device repository. So we're really happy with that. Another thing that we're adding to the device repository, we're currently in the design phase, is to be able to output normalized payload codec. And that means that currently decoding the payload from binary to structured data is not typed. So there can be different data structures that are being used by different end devices. But very often you may want to have a normalized structure. So if you have a temperature sensor, for instance, you just want to receive temperature in a unit that you support with the data fields and the field names that you can interpret. So we are currently working on normalizing the output from the decoded payload into a format that can be supported by all end devices. So more on that also later this year. We use the device repository extensively in the console. So here you see a video of adding a device in the console, so you can select the brand, the model, and then it loads the available versions and also the regions that are supported by the device. And the only thing that you then have to add is device-specific information. We're going to make this even easier with the things join server. So as you see here, you still need to enter your join UI, def UI, and maybe also your LoRaWAN root keys. But ideally, the root keys are not sent to you, but they are on a join server. And this is what we're also launching this year. So the things join server. What is a join server? So a join server is a critical component in a LoRaWAN network that is used for activating devices. So when a device sends a join request to join a network, the network server contacts the join server to activate a device. And what the join server does is that it authenticates the network server. So it decides which network is going to activate the device. And it also derives the network session keys and the application session key that are then securely sent to the network server and the application server. Today, a lot of people are not using join servers like third-party join servers. So they basically enter the root keys in the network server and then the network server activates the devices. So why would you need to use an external join server? And that is really for security, primarily, because ideally you don't want to expose, as a device maker, you don't want to expose your root keys ever, because that makes it really hard to move devices between networks. It's also to be compliant with upcoming regulations. So we expect that the EU and NIST are going to make sure that it will be impossible to actually expose root keys in order to comply with certain regulations. And that is also where a join server comes into place. And if you use a join server as a device maker, you don't have to send your root keys anymore to anyone. And that also makes that you don't have to think about how you distribute root keys. And today that still happens on paper or Excel spreadsheets that are sent as email attachments, and that's not really secure. It also allows end customers to switch networks or to switch deployment. So if your keys are at a join server and your customers want to switch from the thing stack open source to cloud, they can just reclaim the device in cloud without transferring any key material. And as a device maker, finally, since a join server is always used as part of the device activation procedure, it provides you insight in which device is activated by which network and when. So you get an idea of the activity of your end devices once they're out there in the field. So that's what we're announcing. We're building this as a product, and it's really intended to be used by device makers. So we are already engaging with a bunch of device makers that are also already testing with this, and it's really built for them. So we implement all the LoRaWAN functionality. So it supports all the LoRaWAN versions, all the backend interfaces, specifications. It supports device claiming. It's compatible with the LoRa Alliance QR code. And you can use it as a bootstrap join server. So that's basically the first join server that your device uses. And then a handover to the final join server. So that's a new feature that is coming in LoRaWAN 1.2. But you can also just offer your join server as the only join server. And you can still send the root keys to your customers if you want. But you can at least give them the choice to use your hosted join server. And finally, we do all the interrupt testing, all the verifications with all the LoRaWAN network servers. So you don't have to think about that. And then I hear you thinking, oh, I'm a device maker, so I don't know how to operate a join server. So for that, we have different deployment options to make it really easy for you. So we distribute the Things join server fully serverless for Microsoft Azure and Amazon Web Services. And that means that we don't need any compute. You don't need to spin up any virtual machines in your cloud. In case of these public cloud deployments, These are just Azure functions or AWS Lambda functions that are fully managed and scaled by these cloud providers. So there's no compute, there's nothing to worry about, everything scales automatically, and that works really well. And if you want full control, if you are comfortable with operating cloud services, you can also use the Docker or Kubernetes distribution. And finally, if you don't want to bother with any deployments yourself, we can also do that for you. And it will be a white label joint server that's owned by you but operated by us. If you want to get started with this as a device maker, as a systems integrator, or as a distributor, please reach out to us, sales@thetingsindustries.com, and we can help you getting onboarded today. So that's the technical update. Thanks a lot for watching. I will be joining the live Q&A later today, and for now, enjoy the conference. Thank you.